Okay, here we're doing 3.1, number 35 from Openstax Precalculus. Okay, we're taking this 3 plus 4i and we're going to divide by 2 minus I. And the idea is that we want to write our answer in the form a plus by bi. So we write the final answer in the form a plus bi. And that's our standard form. Now where a and b are real numbers. Now, we are going to use this idea, which is that if we multiply a complex number times its conjugate, what do I get? Well, first of all, what's the conjugate? The conjugate for a plus bi is a minus bi. I am going to show a lot of steps here. I have a plus bi times a minus bi, and that gives a squared minus parentheses bi squared. But that gives a squared minus b squared I squared. So we also have, and we're going to use here, that I squared is equal to -1. And that leads us to a squared plus b squared. So that looked like a lot, and we don't want to write that a lot each time if we see that there's a formula. That if I have a complex number and I multiply by its conjugate, then I have this formula, a plus bi times a minus bi gives a squared plus b squared. And I showed all the work right there to explain why that's true. But sometimes we don't want to keep drawing on all the work. We want to just, use a formula. So, I'm using the fact that I squared is equal to -1. These little bullets are I don't know if they're that good to use in math. It's carried over from some other programs. Okay, so I didn't even solve the problem. What I want to do here is I want to take this 3 plus 4i and I want to multiply the conjugate. I want to multiply the denominator by its conjugate. Okay, so I'm going to multiply the denominator by its conjugate. I'll pick a different color, like this cranberry color here. The conjugate of 2 minus I is 2 plus I. So I want to multiply by the conjugate. And the reason is I don't want a complex number in the denominator. That's where this is all leading to. I don't want a complex number in the denominator. And the denominator then will lead to, using this formula, the denominator will simplify pretty easily to 2 squared plus -1 squared. Or just 2 squared plus 1 squared. Because you have a complex number multiplied by its conjugate. Oops. See, just right here, it says a plus bi times a minus bi is a squared plus b squared. So 2 plus I times 2 minus I is 2 squared plus 1 squared. Now, let's look at the numerator. When I have that part in cranberry, or whatever red that is, when I multiply the denominator 2 minus I times 2 plus I miss something. I guess on purpose, maybe it wasn't a good idea, but I miss multiplying the top by the same thing. Why do I have to multiply the numerator by the same thing? Well, because that's like multiplying by 1. 2 plus I divided by 2 plus I is 1. So I'm not changing the value of the whole expression if I do that, if I just multiply by 1. Okay, now I'd say the hard work is looking at the numerator where I have to use FOIL. I have to expand that. 3 times 2 is the first. 3 times I is the last. 4i times 2 is the inner. Oh my, looks like I need more space. Okay. And then plus, hold on. Then plus 4i times I. Okay, in the denominator, it gives us 4 plus 1. I sort of really don't like anything that's cramped. like this. I think this is one of my big things that I don't like. It's when everything gets all stuck together. When it's just because I could just make some more space. Okay, but I think it's all right. All right, I have 6 plus 3i plus 8i makes 6 plus 11i. And then I use that I squared is negative 1. Okay, I need to move this. This is for the next problem. I'm going to move that down there. All right, so I squared is equal to negative 1. This guy right here is negative 1. I squared is negative 1. So I'm going to get then 6 minus 4 is 2 plus 11i all over 5. And then to really write that in the standard form, I need to write this as 2/5 plus 11/5. And that is our answer. There's so many steps that I feel like I need to double check. And I don't think that's that easy to double check. I'm seeing if I can just do it really quickly in my head. I feel like maybe I did do it wrong. No, it's good. Hold on. All right, I guess I can look in the back of the book, but I can look more carefully. Okay, so anyway, that's the end of that problem.